Good morning, my dear student. The third chapter is the motion in a straight line. In this chapter, we are going to discuss about scalar and vector quantities. All the physical quantities can be classified into scalars and vectors quantities. Then define what is meant by scalar quantities and what is meant by vector quantities. So, first one, scalar quantities. Physical quantities which has only a magnitude but no direction. Such a physical quantities are called scalar quantities. Magnitude means numbers. So pure number. So it doesn't have any direction. For example, mass. So 2 kg, 3 kg. So it has only a numerical value but doesn't have any direction. Length, time, speed, etc. are the best examples for the scalar quantities. Then vector quantities. Physical quantities that have both magnitude and direction are called vector quantities. The examples for vector quantities are displacement, velocity, acceleration, etc. Representation of a vector. The vector has magnitude and direction. So the vector is represented by a straight line with an arrow head. The length of the vector represents the magnitude and arrow mark represents the direction of a vector. And in this P is a vector and point O can be called as tail and A is called as head of the vector. So the vector is represented like this. Then depending on the direction and magnitude, the vectors can be classified into different types. In that is parallel vectors. Two or more vectors parallel if they have same direction. Here we are considering the two sets of parallel vectors. R1 and R2 are the two vectors having same direction. Similarly, V1 and V2 are the two vectors. So they have same direction. Then V1 and V2 are called as parallel vectors. Anti-parallel vector. Anti-parallel vector can be defined as vectors having opposite direction are called anti-parallel vectors. That is, R3 is the one of the vector. The direction is given by this, and R4 is another vector which is opposite to the first one. Then R3 and R4 are called as anti-parallel vectors because the direction is opposite to each other. Next one is equal vectors. Two parallel vectors having the same magnitude. The magnitude must be same but represents the same physical quantity. Then you can call it as equal vectors. A vector having same magnitude. In this anti-parallel vectors, two vectors opposite to each other, then you can call it as anti-parallel vectors. In case of negative vectors, a vector having same magnitude but the direction opposite to that of the given vectors. So vector P has a 4 magnitude and Q also must have a 4 unit, and these two are opposite to each other. Then we can call it as a negative vector. Fifth one is concurrent vectors. Vectors having common initial point are called concurrent vectors. Concurrent vectors can be called as co-initial vectors because F1 and F2 are the two vectors having common initial point O. Because of that, co-initial vectors. Concurrent vectors can be called as co-initial vectors. Sixth one is coplanar vectors. Vectors in a plane are called coplanar vectors. So vectors lying in a plane are called coplanar vectors. Seventh one is zero vector. A vector whose magnitude is 0 is called zero vector. The another name for zero vector is null vectors. So zero vector can be called as null vector. Define null vector. On that case also you should write a vector whose magnitude is 0 vector. Eighth one is unit vector. A vector having unit magnitude then is called unit vector and represented by the formula, and unit vector is a dimensionless quantity.